Then we want to find the equation in the form m upon n. m upon n में हमें इक्वेशन चाहिए, तो हम किसकी वैल्यू निकालेंगे? L नहीं चाहिए, यहाँ से L की वैल्यू फाइंड आउट करेंगे. So L is minus bm plus cn upon a. Now we will have to fill the value of this. So put the value of L here, fmn plus gnl minus bm plus cn upon a plus hm bm plus cn upon a, that is equal to 0. Now afmn minus bm bgmn minus cgn square minus bhm square minus hcmn equals to 0. Now we want to find the equation m upon n. So take plus negative sign common, bh m square cg n square mn common from these three terms, and after taking negative common, what we get? bg plus hc minus af mn. Now divide the whole equation by n square, bh m upon n square bg plus hc minus af m upon n plus cg equals to 0. Now this is quadratic in m upon n, so its roots will be m1 n1 and m2 n2. Now product of roots, m1 upon n1 into m2 upon n2, c upon a is bh. So what we get here? m1 m2 upon cg, n1 n2 upon bh. b goes on this side, b m1 m2 upon g, c goes on that side, right hand side. We can write it as m1 m2 upon g upon b, n1 n2 upon h upon c. Let this equation as 2 and 3. This was 1. Now from 2 and 3, what we found from 2 and 3? From 2 and 3, L1 L2 upon f upon a is equals to m1 m2 upon g upon b, n1 n2 upon h upon c is equals to lambda say. So n1 l2 is equals to lambda f upon a, m1 m2 is equals to lambda g upon b, n1 n2 is equals to lambda h upon c. Now two lines are perpendicular if L1 L2 plus M1 N2 plus N1 N2 is equals to 0. The given lines are perpendicular if L1 L2 plus M1 M2 plus N1 N2 is equals to 0. This is the condition. So lambda f upon a plus lambda g upon b plus lambda h upon c is 0. By taking lambda common, f upon a plus g upon b plus h upon c 0. This is what we want to prove. If two lines are perpendicular, then the condition is this. The given lines are parallel. Given lines are parallel if they have equal roots. If they have equal roots. और roots equal कब होते हैं? When discriminant is equals to 0. Discriminant, that is b square minus 4ac, is equals to 0. So what is that? AF plus, its value is AF plus BG whole square minus 4AGBF is equals to 0. That is A square F square B square G square C square H square minus 2ABFG minus 2BCGH minus 2ACHF is equals to 0. Question number 13 is same as question number 12. You can try it by yourself. Show that straight line whose direction cosines are given by AL plus BM plus CN is equals to 0 and UL square plus VM square plus WN square is equals to 0 are perpendicular if A square V plus W plus B square U plus W plus C square U plus V is equals to 0 and parallel if A square upon U plus B square upon D V plus C square upon W is equals to 0. इसी में भी पहले हम फर्स्ट इक्वेशन से n की वैल्यू निकालेंगे, उसे इस इक्वेशन में पुट करेंगे. सो क्वाड्रेटिक विल बी ऑफ द फॉर्म L अपॉन m. देन फर्स्ट इक्वेशन में से L की वैल्यू निकालेंगे, इसमें पुट करेंगे. देन क्वाड्रेटिक विल बी ऑफ फॉर्म m अपॉन n, सेम एज द प्रीवियस क्वेश्चन. यू कैन ट्राई इट. नाउ द नेक्स्ट वन इज if the edges of rectangular parallelopiped are ABC, prove that angle between four diagonals are given by cos inverse A square plus minus B square plus minus C square upon A square plus B square plus C square. Let O be the origin. Let O be the origin. A has coordinates A0, 0, B 0, B0 along y-axis and C along z-axis 0, 0, C. These are point P, Q, R, S. 0, B, C. Q is A, B, 0. P is A, B, C and S is A, 0, C. Since direction ratios of line segment joining 2 points x1, y1, z1, x2, y2, z2 are x2 minus x1, y2 minus y1 and z2 minus z1. Therefore, direction ratios are proportional to direction ratios of diagonals OP, AR, BS and CQ are OP, P minus origin, ABC, direction ratios of AR, R and A, R has 0, BC, 0 minus A, B and C, BS, B and S, A minus 0, 0 minus B, C minus 0, CQ, C and Q, 0 minus A, 0 minus B and C minus 0. So direction ratios are ABC minus ABC, A minus BC, A, B and minus C. If we take negative common, CQ is here. So A, B and minus C. Now we want to find the angle cos theta. Cos theta 1, this is the angle between, theta 1 is angle between OP and AR. OP and AR. This is of OP, AR, BS and CQ. Multiply A minus b square and c square. Now we get minus a square plus b square plus c square upon a square plus b square plus c square. Let theta 2 be the angle between OP and BS. Then cos theta 2 A into A minus B into B C into C upon A square B square C square square root. Similarly here, so we get A square plus B square plus C square. Now theta 3 is angle between CQ and BS. Then cos theta 3, theta 2, then theta 3 is angle between CQ and BS, A into A minus B into B minus C into C upon A square plus B square plus C square again. Now similarly the angle between the other pairs of diagonals can be obtained. Therefore we get theta as cos inverse of A square plus minus B square plus minus C square upon A square plus B square plus C square. Show that angle between diagonal of a cube is cos inverse 1 by 3. Angle between the diagonals of a cube, this is z-axis, y-axis and x-axis. A 0 0, y-axis, so 0 A 0, 0 0 A, and this point is P Q R S. This is along x and y, therefore the coordinates are this. This is along y and z, 0 A, P is A. This is along x and z, so A 0 A. Now write down, let A be the length of edge of cube and let one corner be at origin. One corner be at origin. OP, AR, BS and CQ are diagonals of cube. Direction ratios of OP and AR are direction ratios of OP. A minus 0, A minus 0, A minus 0. Direction ratio of AR 0 minus A minus 0, A minus 0. Let theta is the angle between OP and AR. Then cos of theta minus A into A plus A square upon A square plus A square plus A square, A square plus A square plus A square. So we get A square upon square root of 3A square. A square upon 3A square, that is 1 by 3. So we get theta as cos inverse 1 by 3. Similarly, between the other diagonals, we can check the angle, that is theta is cos inverse 1 by 3. Hence, the angle between any two diagonals of a cube, is cos inverse 1 by 3. Now the next one. A line makes angle alpha, beta, gamma and delta with 4 diagonals of cube. Prove that cos square alpha plus cos square beta plus cos square gamma plus cos square delta is 4/3. Let A be the length of edge of cube and one corner be at origin. This is along x-axis, y-axis point B and z-axis is point C. This is along z-axis, so 0, 0, A. Along y-axis, 0, A, 0. P is A, B, C. This is along y and z, so x coordinate is 0. And this is along x and y, so z coordinate will be 0. This is along x and z, so y coordinate is 0. And this is the point of origin. Now write down direction ratios of OP, AR, BS and CQ are proportional to OP is A minus 0, A minus 0 and A minus 0, that is A and A. Direction ratios of A are 0 minus A minus 0, A minus 0, minus A. Direction ratio of BS 0, A minus 0, 0 minus A minus 0. So A minus A and A. CQ, Q is A minus 0, A minus 0, 0 minus A and minus A. Direction ratios of OP, AR, BS and CQ are proportional to this. Let the direction ratio of line are proportional to LMN. Suppose this line makes angle alpha, beta, gamma, delta with OP, AR, BS and CQ. Then cos alpha OP के साथ AL plus AM plus AN, AL plus AM plus AN upon square root of A square, L square, M square, N square. So what is A into L plus M plus N square root of 3 A square A square root of L square plus M square plus N square. So we get L plus M plus N square root of 3 square root of L square plus M square plus N square. Now if beta is the angle between the line and the diagonal AR, then minus AL plus AM plus AN square root of 3A square root of L square plus M square plus N square. A is common, A will get cancelled, so we get minus L plus M plus N upon square root of 3 square root of L square plus M square plus N square. Now gamma is the angle cos, gamma is the angle between line and BS. So A into L minus A into M plus A into N square root of 3A square root of L square plus M square plus N square. So L minus M plus N upon square root of 3 square root of L square, M square and N square. Now delta is the angle between line and the diagonal CQ. AL plus AM minus AN upon square root of 3A square root of ln square, square of denominator 3 L square plus m square plus n square, plus cos square beta. Cos square beta is minus L plus m plus n square upon 3 L square plus m square plus n square, plus L minus m plus n whole square upon 3 L square plus m square plus n square, plus cos square delta L plus m minus n whole square 3 L square plus m square plus n square. Now we have to solve this. What is the formula for a plus b plus c whole square? That is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. A square plus b square plus c square 2ab 2bc 2ca. A square plus b square plus c square 2ab 2bc 2ca. A square plus b square plus c square 2ab 2bc 2ca upon 3 into L square plus m square plus n square. Now cancel that down. 2ln 2ln 2lm 2lm plus 2mn minus 2mn plus 2lm minus 2lm minus 2nl plus 2nl plus 2mn minus 2m. So we get 4 times L square plus m square plus n square upon 3 L square plus m square plus n square. That is equals to 4 by 3. This is what we want to prove.